Hello, thank you for watching this video. So in this video I'll be doing question 4 of November 2022 question paper, Physical Sciences paper 1. This is question 4, which is the momentum. I'm going to read the statement and then answer the questions that follow. So, trolley X of mass 1.2 kg travels at 8 meters per second east and collides with trolley Y of mass 0.5 kg, which is initially at rest. So you have two trolleys, trolley X and trolley Y. Trolley X have a mass of 1.2 kg and traveling at 8 meters per second eastwards. And trolley Y have a mass of half a kilogram and is at rest initially. Ignore all frictional effects. Let's continue. The velocity time graph below, which is this one here, shows the velocity of trolley X before, during and after collision with trolley Y. The velocity time graph, which you see here, shows the velocity of trolley X before, during and after collision. So here, this is the velocity of trolley X before collision. Here, this is the velocity of X, trolley X during collision. And here, this is the velocity of trolley X after collision. I hope this is clear. Then, let's go to the questions that follow. 4.1, state the principle of conservation of linear momentum. So they want you to state the principle of conservation of linear momentum. This principle, it states that if you have an isolated system, right, then the total linear momentum is conserved, which means now the momentum before your collision, it should be the sum of your momentum before collision, which is the total linear momentum. It should be the same as the total linear momentum after collision. This is what this says. I'm not going to write the entire thing. I will just write the mathematical representation of this thing, which is the sum of initial momentum should be the same as the sum of final momentum. This is what this thing says. It says in an isolated system, the total linear momentum is conserved. That means in an isolated system, the sum of the initial momentum should be equal to the sum of final linear momentum. This is what this thing says. This is what this principle is telling you. Then let's go to the next question, 4.2. Calculate the magnitude of the velocity of trolley Y immediately after the collision. So they want us to calculate the magnitude of the velocity of trolley Y. So the one that we have here, we have initial velocity of trolley X. So this is the initial of trolley X here, VI, and then this is the final velocity of trolley X after the collision. And this one here happens during the collision. So we can note that down. We can say, okay, V of trolley X initially, it was 8 meters per second, right? V of trolley X finally, it was 4 meters per second, right? And the mass of trolley X was what? 1.2 kilograms. Then let's go to trolley Y. What is the initial velocity of trolley Y? Vy initially, it was 0 meters per second because it was at rest initially. The final velocity of Y, trolley Y, is what we are looking for. What is the mass of trolley Y? The mass of trolley Y is half a kilogram. So, like you see in physics, especially at grade 12, if they ask you to state something, whatever that you are stating, if it's a law, it's a principle, it's a theorem, it's likely that you will apply it on the next question. So now, they asked you to state this. You said that in an isolated system, the total momentum before collision is equal to the total momentum after collision. Or the sum of momentum after collision initially is equal to the sum of momentum finally, right? So this is the principle that you will use to find the final velocity. you use this principle. So you write it down. You say, okay, the sum of initial momentum is equal to the sum of final momentum, right? What is your initial momentum? So it should be, you know that momentum is called mv, right? So if you want the initial momentum, you should add the initial momentum of trolley X and add the initial momentum of trolley Y. So you will say, okay, I have P Y initial, right? Plus P X initial. So this part, when you add this sum, this is the initial momentum of trolley Y, and this is the initial momentum of trolley X. So this is the initial part. So this part is this part. So this should be equal to what? The momentum of trolley Y final plus momentum of trolley X final. So this part here is this part here. So this sigma means sum of the initial momentums. Here is the initial momentum of X, here is the initial momentum of Y. Sum of the initial momentum of sum of the final momentums here. Here is the initial momentum of Y, here is the initial momentum of X. You are adding them. Then you expand this to this thing here. So you said P is called mv. So this is going to be the m of Y. M of what? Of Y. V R a V Y initial, which is the initial velocity of Y, plus mx V X initial is equal to what? My V Y final, right? Plus mx V X final. Same thing. This is the initial momentum. Here is the initial momentum of Y. Initial momentum of X. Here is the initial momentum of X. Final momentum of Y. Final momentum of Y. Final momentum of X. Here is the final momentum of X. So we continue. We say, okay, our mass of Y. What is our mass of Y? It's 0.5 kg. Plus initial momentum of Y. This one, Y was initially addressed. So its initial velocity is 0. Plus mx, what is mx? Mass of x, which is 1.2. Time the initial velocity of x. What was the initial velocity of x? Your initial velocity of x was 8, right? Is equal to my, right? So your my is the mass of trolley Y, which is what? 0.5 times VYF, which is the final velocity of Y, which is what we're looking for, plus mx, mass of x, what is it? It's 1.2 times the final velocity of x, which is 4. Then this is what we're looking for, solving for that. So this times this is 0. This times this, plus this time this, can punch that in your calculator. So 1.2 times 8, this is 9.6, is equal to half of VYF, which is the final velocity of Y, plus 1.2 times 4, which is 4.6, 4.8, I think. 1.2 times 4, yeah, 4.8. Then you solve for this. Transpose this guy to the other side. We have 9.6 minus 4.8, right, is equal to 0.5 VYF. This minus that, we have 4.8 is equal to 0.5 VYF, then divide by 0.5, you divide by 0.5. So V YF, which is the final velocity of trolley Y, is equal to 9.6 meters per second. It should also be eastwards, because you can see the sign. It came out the same as our eastwards direction there. So you can say therefore V Y final is equal to 9.6 meters per second. That is your final velocity. So you can also check this now and see if your answer is correct by punching this on the calculator, which is 9.6, and then also substitute this here and see if you'll find 9.6 this side. 0.5 times 9.6 plus 4.8. Yeah, it is 9.6. So this is your final velocity here. This is how you do this part. So I'll clean the board and do 4.2.2. Okay. So now, let's go to 4.2.2. Calculate the magnitude of the average net force that trolley X exerts on trolley Y during the collision. So they want us to calculate the average net force that trolley X exerts on trolley Y during the collision. So how do you find this? You say, okay, your impulse, right, is equal to what? Change in momentum, right? So you know your impulse is average force times time, which is equal to the change in momentum. So what do we have here? You know that this is equal to m Vf minus Vi, V initial of X. So we want to find the average force, right? So we have everything here. We have the initial velocity, final velocity, the mass of the trolley. Now, we want the average force. What about the time? So this time here is the time of the collision, the period of the collision. How long did the collision take? So the collision started here at 20.1 and ended at 20.2 seconds. So now, is this time here that is this one here? So the time, this time is the duration of the collision. The collision started at 20.1 seconds and ended at 20.2 seconds. So the time difference here is the time that you are referring to here. So what do? Say, okay, F average times time. What is your time? It's this time here. So you say, okay, 20.2 minus 20.1, right? Which is the difference between these two times that you have here. It's equal to M. What is your M of the trolley X? It's 1.2. V final of trolley X is 8. It's 4. Final velocity of trolley X. Minus initial velocity, which was 8. So what do? Say F average times this time this is 0.1 is equal to this times that, which is 1.2 times -4, right? So V average, F average, right, is equal to 1.2 times -4 all divided by 0.1, divided by 0.1 both sides. So your average force is equal to, you punch this in your calculator and see what comes out. Say 1.2 times minus 4 over 0.1 is negative 48 newtons. So this is average force exerted by trolley X on trolley Y. It's 48 newtons. Newtons. Yeah. So let's go to the next question, 4.3. Is the collision elastic or inelastic? That's what they're asking you. What do they mean by elastic? So, if your collision is elastic, right? What that means is the sum of the initial kinetic energy should be the same as the sum of the final kinetic energy. Which means if you sum the final initial kinetic energy, you should get it should be the same as if you sum the initial kinetic energy of the trolleys, it should be the same as the sum of the final kinetic energy of the trolleys. That's what they mean by elastic collision. Then, if it's inelastic, then if you sum your initial kinetic energies, right, they should not be equal to your final kinetic energies. That's what they mean by this. So they're asking you if this collision is elastic or inelastic. So what you need to do is to sum your initial kinetic energies and sum your final kinetic energies and compare them. Then that's how you will be able to decide if it's initial. That's how you will be able to decide if your collision was elastic or inelastic. Let's do that. So, what do we say? We say, okay, the sum of EK initial is equal to what? It's equal to the initial kinetic energy of X plus the initial kinetic energy of Y, right? So what is it? Half M X V Xi, which is the initial squared, plus half of My, mass of trolley Y, final velocity of, initial velocity of trolley Y, not X. So what do? Calculate. So you say the sum of EK initial, so half of M, what is the M of X? 1.2. Initial velocity, what was it? It was 8 squared plus half of what? Plus half of mass of Y, which was the half, times the final of Y, which was what? 9.6, right? I think it was 9.6 all squared. So the sum of the initial kinetic energy is equal to this. So you add this in a calculator. So half of 1.2 times 8 squared plus, actually sorry, this was 0 here. The initial velocity of trolley X was 0. So it's this plus 0. Patch this. What do you get? Get that your initial kinetic energy was 38 0.4 joules. So this is the initial kinetic energy. Now, go and calculate the final kinetic energy of trolley, or the final sum of your kinetic energies. Let's go to that. Clean the board first. So you say, okay. So you say, when the final kinetic energy, so EK, so it's the sum of the final kinetic energies, right? Which is going to be equal to what? EK, final kinetic energy of X plus final kinetic energy of Y, right? Which is equal to 1 over 2 mass of X V final velocity of X squared plus 1 over 2 mass of Y final velocity of Y squared. So final sum of EK finals is equal to what? 1 over 2. What is this? This is the mass of X, which is 1.2. Final velocity of X was 4, right? Plus 1 over 2 mass of Y is 0.5. Final velocity of F was 9.6 all squared right there. Can you punch this in your calculator as well? Say, okay, 1 over 2 times 1.2 times 4 all squared plus 1 over 2 times 0.5 times 9.6 all squared. What do we get? We got that the sum of the final kinetic energy is equal to 2.64 joules, right? Therefore, we can see that the sum of the EK, initial kinetic energy, is not equal to the sum of the final kinetic energy. Therefore, our collision is inelastic. Because we said that if it is elastic, then the sum of the total of the initial kinetic energy should be the same as that of the final. And then if it's inelastic, the sum of the initial kinetic energy is not the same as that of the final. That is what we said. So we are done with this.